So when you go to evaluate on the unit circle, sine is your y value, cosine is your x value. Does that ring some bells? Like we remember where it comes from is SOHCAHTOA. Sine is opposite over hypotenuse. The opposite is the y value, but the hypotenuse for the unit circle is, what's the hypotenuse? 1, because it's a unit circle, it's 1 unit. So y over 1 just is y. And then cosine is the same, it's adjacent over hypotenuse, but that would be x over 1, which is just x. Anyway, that's where it comes from. Tangent is sine over cosine, so that is y over x. And then these three are the reciprocals. But my belief is, and if you had me in pre-calc, I preached about this, if you say it correctly, you will think it correctly, and then your answers will be correct. So I don't allow people to say cos and tan and sin and cot. You say it correctly, you'll think it correctly. Your words and your thoughts are connected. What is this one called? Cosecant. Good. Now I'm going to write 1 over y, but you want to think of that as just flipping y. Just flip y. And then this one is called secant. Good. And then this one is cotangent. Okay. Now for all of these, I require you to draw a circle or a triangle. That is your work. You remember that from 2 years ago. Okay. Now pi over 2 is going to be a circle. So you're going to draw yourself a circle. Is it up, down, left, or right? Up. Perfect. It is the point 0, 1. That is your work. That is the amount of work that I require for that. Now tangent is y over x. So that's going to be 1 over 0. And I know then everyone has this crisis. Oh my gosh, is it 0 or is it undefined? Well, it is one or the other. It's undefined because you can't divide by 0. And that means if you graph it, which we're going to do later if you look at number 11, what does that mean the graph has at pi over 2? An asymptote. All right, pi over 3. What quadrant is pi over 3 in? First. Good. So here's your pi over 3 triangle. Across from pi over 3 is your square root of 3 over 2. A lot of people will just remember the 3's go across from each other. Or you could remember that's the larger angle, so it's the larger side. Anyway, then the 1/2 goes here. That is your work. I don't ask for a lot. It's a triangle that's labeled. That's the work. Now, sine is which part of that? The y value, which is square root of 3 over 2. I love these. Trig is just my favorite. All right, what quadrant is 3/4 in? Quadrant 2. And your reference angle is pi over 4. That means both sides square root of 2 over 2, but what? Yeah, x is negative. Beautiful. That is your work. And then you answer the question. Cosine is the x value. That's this one. Negative square root of 2 over 2. All right, what quadrant is 7/6 in? 3, good. I think I did 1 in each quadrant. I tried to do like an example of each. Your reference angle is pi over 6. Across from that is a 1/2. And so the other side is square root of 3 over 2. But you're in quadrant 3, so they're both negative. So that's your work. Cosecant means you flip the y value. This negative 1/2 is the y value. So if you flip that, it is negative 2. All right, pi is going to be a circle, up, down, left, or right? Left, good. That's your work. Secant means you flip the x value. The x value is negative 1. If you flip negative 1, it is still negative 1. 1 over 1 is 1. It's just negative. right? And then 11 pi over 6 is in the fourth quadrant. Your reference angle is pi over 6. What's across from the pi over 6? 1/2. It's the little angle, so across from it is going to be the little side. Think of it like a sixth of a slice of something is real small. That means the other side, square root of 3 over 2. Which one gets the negative? Yeah, the 1/2, the y value. Perfect. All right, that's your work. Cotangent is x over y. So that's going to be square root of 3 over 2 over negative 1/2. No panicking. I realize that looks horrible, but the 2's cancel. And it's just going to be negative square root of 3. Now the other ones are arc. That means inverse. Pep talk. All that means is you're doing what we just did backwards. Instead of having the angle, like the pi over whatever, and getting the side with the square roots of things, you have the side and you're getting the angle. So your answer should be something with a pi in it. Your answer is an amount of rotation. It's just backwards. You're being given the answer looking for the question. Okay. Now the thing about these is you're very, very restricted to the quadrants you're in. Do you remember this sort of which quadrants you're allowed? Yeah, cosine and something else. Cosine, well remembered. Cosine and secant, they're the even ones. They're in quadrants 1 and 2. All the others are in 1 and 4. Do you remember being like very like fenced in? If you don't, that's fine. I'm gonna go over it right now. So if it's positive, you're in quadrant 1. If it's negative, you're in whatever the other one was. So for cosine, that's quadrant 2. Here's the other way you can remember that. Cosine is the x value. And if this is negative, you had to go to the left for your x value. Do you get what I'm saying? Like, okay, thank you for heads nodding. Anyway, your negative square root of 3 over 2 goes here. That means the other side is 1/2. That means the angle is pi over 6. Now hold on. Pi over 6, not your answer, because good, because it's the amount of, oh gosh, those are lovely, lovely, lovely human beings. 5 pi over 6. It's how far you rotated to get there. Now I put arctangent of 1 because of all the ones that could show up on the AP exam, that's the one I've seen the most often because it's the one that's tricky and they're evil and they're going to try to trick you. Now, the 1 makes you think of like the up, down, left, right. But for tangent, it isn't. It's in quadrant 1. How do you end up with 1? Perfect. It's when they're the same, because anything over itself is going to give you 1. So your answer is pi over 4. You would kind of do well to just know tangent inverse of 1 is pi over 4. They throw that one in there a lot because it's the tricky one. Okay. Now I'm not going to do all the graphs. I'm going to do one of each of the shapes. So we're not doing all 6. We're only going to do 3 of them. We actually did sine last time. So I threw cosine on here. It's a wave. If you remember where it starts, then you're good. So where does cosine start? At 1. So if you start at 1, 0, 1 to be like particular, and then just go and wave from there. It's going to wave in between -1 and +1. Does anyone remember what secant and cosecant looked like? Like just the shape of them? I'm not looking for a specific thing, but just like vaguely what they looked like. Like this one was a wave. Do you remember? Like the U shape. So what you did is you turned the wave inside out is what's happening. Like you took the wave because it's reciprocal. It's going to go the other way. So secant is the reciprocal of cosine. Still going to start at 1. And then you're going to have an asymptote every other time. And you end up with those smiley faces and frowny faces. Don't write this on your paper, but just to show you what I'm talking about, do you see how, I'm going to make it pink because I think that's the one that showed up the best. Do you see if I draw the cosine wave in between? How it's like you turned the wave inside out is what happened there. Don't draw that on yours because I don't want you to mess up your picture, but that's like just to give you a visual of what happened there. And then do you remember what shape tangent and cotangent were? Yeah, they were like an infinite number of those wiggly things that looked like cubic graphs. Remember what I'm talking about? Okay. The way I remember tangent is it starts at 0. And then tangent of pi over 4 gives you 1. Anything over itself is 1. And then you get the asymptote. And the pattern is -1, 0, 1 asymptote. It goes -1, 0, 1 asymptote. And once you get the ball rolling, then you can kind of fill in the rest of the pattern. And you get an infinite number of these wiggly things. Cotangent decreased instead of increased. The wiggles went the other way. But that one I have seen come up. Visually, it's just good to know that tangent starts at 0 and that you have the asymptotes at pi over 2 and negative pi over 2. Like that's where your wiggle goes in between those. So just having like a rough idea of that. And then I threw a couple of equations on here because solving is something that you also need to do. I'm just going to teach these, like not question you because I know that these can be a little bit tedious. You're still just getting x by itself though. So first step, you're going to add over that square root of 3. You're adding that to the other side. Oh, I lost my variable. That's not good. And then you're going to divide by 3. Now, you're probably like, but hold on, square root of 3 over 3 is not on the unit circle? Go ahead. Or do you have the answer? Or are you going to tell me what to do next? Or did you have a question?
No.
Yeah, go ahead.
It has something to do like 1/2 and the square root of 3 over 2. Not like the square root of 3, but it's like the other.
Yeah, you have to back up. Like you have to go backwards in your mind to the 1/2 and the square root of 3 over 2. What I'm going to do is unrationalize it to 1 over square root of 3. If you were to rationalize that, you would get square root of 3 over 3. I just did it backwards. If you're like, hey, that's really kind of hard. Yeah, it is. If I'm going over it, I thought it would be a good thing to review. And so then which one goes where? 1/2 square root of 3 over 2. 1/2 goes on the top. Square root of 3 over 2 goes on the bottom. But what I tell everyone in pre-calc is, if you're like, hey, that was hard, you're right. If you can't figure it out, it is either 1/2 over square root of 3 over 2 or square root of 3 over 2 over 1/2. So you have a 50-50 shot if you just flat out guess. Okay, so don't stress about it. All right, now we're going to figure out what quadrants we're in. Tangent is positive in 1 and 3. Sorry about the hole in the paper there. And tangent is y over x. So the 1/2 is the y. The square root of 3 over 2 is the x. We're nearly there. You're probably like, oh my gosh, how much more is this to the problem? The goal is the angle. That's what we're trying to find. So what's your angle across from the 1/2? Pi over 6. And I don't label the other triangle because one is sufficient. The other one's the exact same triangle, just reflected. So your answers are pi over 6. And then what's the one in the third quadrant that's the 6? Yep. Perfect, 7 pi over 6. So those are your two answers. I should have put that one last because that's the hardest one. Bless you. The other ones, bless you, the other ones aren't going to be nearly as hard as that. I should have put that one last. Oh, well. What would you do first for this one? Yep. -2. And then divide by square root of 3. Now, whenever it's secant or cosecant, you want to turn it into sine or cosine because those are a whole lot easier. Which one is the flip of secant? Cosine. So it's going to be cosine equals, and then just flip that over, and you're like, oh my gosh, the world makes sense yet again. It's square root of 3 over 2. So just do the reciprocal. Now we figure out our quadrants. Cosine is negative where? Well, cosine is x. So second quadrant and third quadrant. Perfect. Nice job. Just watch me point to this because I'm going to run out of space. It's too small. The negative square root of 3 over 2 should be labeled right here, but I don't have space to do it. But that means that this side should be what? The one. Good. Thank you for coming with me on that. Well, I guess I can kind of fit it in there. Just like super tiny. But that means your angle is pi over 6. And so your two answers are the sixth ones in quadrants 2 and 3, which are 5, 5, or 6. Beautiful. All right, one more and then we can play a game. I stuck a squared in this one.
Are we gonna do like rules, like with trigonometry?
The identities. I have a Quizlet on it that we can do today just to practice them. That's a great question. Can I finish this last problem and I'll address that real quick? Okay, so for this one, you're going to add 1 and then divide by 2. Can I do both of those steps at once? Okay, all right. Well, I don't like to skip stuff. I don't want to confuse people, but I added 1 and divided by 2. It came out to a half. Now you're like, oh, good, a half is on the unit circle. But there's one more step. To get rid of the squared, square root. When you put a square root, you have to put plus and minus. Square rooting fractions, I know, it's like, it turns into a disaster. Just do the numerator and do the denominator. What's the square root of 1? Good. What's the square root of 2? Square root of 2. And so that is plus and minus square root of 2 over 2. I'm going to just verbally take you through this because on the AP exam, you don't have to draw this. You just need an answer. And not telling you to be lazy. I'm telling you to be efficient. What quadrants are you in since it's plus and minus? All of them. And what's the angle for this? Pi over 4. So let's list them out. Pi over 4. 3 pi over 4. What else? What's the next one? 5 pi over 4. 7 pi over 4. And those are your answers.